Let's look at section 5.1a, lines. Today we will discuss transversals and angles with regard to lines, and then we'll complete the lesson in a separate session. Our essential question is, how can algebraic concepts be applied to geometry? Well, we'll learn how we can use some of the things we've learned about solving equations to apply them to geometric concepts. When two lines intersect in a plane and form right angles, they are called perpendicular lines. You might see this symbol for perpendicular. Two lines are called parallel lines when they're in the same plane and do not intersect. And you might see this symbol when we're talking about parallel lines. So let's talk about transversals and angles. While I'm sure you've heard of perpendicular and parallel lines before, you may not have discussed the relationship between lines that are parallel and cut by what we call a transversal. So a line that intersects two or more lines is called a transversal. When that line intersects parallel lines, special relationships are formed. But each time that the transversal intersects two lines, there are certain things that you're going to find true. The first thing you're going to find is that you have interior angles that lie on the inside of the lines. Examples in this picture are angle 3, angle 4, angle 5, and angle 6. They lie inside the parallel lines. You're also going to have exterior angles and exterior angles lie outside the parallel lines. So if we take a look at our picture, we have angle 1, angle 2, angle 7, and angle 8 that lie outside the parallel lines. Now, when the transversal intersects parallel lines, we're going to have some special angle relationships, as I said before, and the first one is going to be alternate interior angles. Alternate interior angles are interior angles that lie on opposite sides of the transversal. When the lines are parallel, their measures are going to be equal, or sometimes I will say congruent. So the measure of angle 4 in our picture is equal to the measure of angle 6. These are alternate interior angles. They're inside the parallel lines on opposite sides of the transversal. When we read this, we read the measure of angle 4 equals the measure of angle 6. We also have the measure of angle 3 equals the measure of angle 5, because they are also alternate interior angles. The next relationship that is formed is alternate exterior. And we'll go to the next page for angles. And these are going to be exterior angles that lie on the opposite sides of the transversal. When the lines are parallel, their measures will be equal or congruent. Same thing. So the measure of angle 1 equals the measure of angle 7, and the measure of angle 2 equals the measure of angle 8. Notice that they are outside the parallel lines, and they are on opposite sides of the transversal. All right, the next relationship is corresponding angles. And corresponding angles are those that are in the same position on the two lines in relation to the transversal. When the lines are parallel, their measures are equal or congruent. So if we look at our figure, corresponding angles are going to be angle 1 and angle 5. They sit in the same place on the parallel lines. Angle 4 and angle 8, angle 2 and angle 6, angle 3, and angle 7. Next we have supplementary angles. Now these you're going to see, even when you don't have a transversal and two parallel lines, but you also see them in this situation, so we're going to discuss those. Supplementary angles are angles that lie on a straight line and whose measures equal 180 degrees. So if I look here, I've got angle 1 and angle 2. When I add those two together, they equal 180 degrees, which makes sense because we know that the straight line equals 180 degrees. We also have angle 3 and angle 4 that lie on a straight line. 5 and 6, 7 and 8, they are on a straight line. And if I turn this just a little, you can see that 1 and 4, 5 and 8, 6 and 7, 2 and 3 are all supplementary angles. So angle 1 and angle 2, if I add them together, the measure of angle 1 plus the measure of angle 2 equals 180. I can do the same thing with each pair of angles. So the measure of angle 3 plus the measure of angle 4 equals 180. The measure of angle 5 plus the measure of angle 6 equals 180. The measure of angle 7 plus the measure of angle 8 equals 180, and so on. So each of these pairs of angles are going to equal 180 degrees because they lie on a straight line. The next relationship that we're going to look at, vertical angles. Again, you might see vertical angles even when you don't have this type of figure, but vertical angles are going to be important for us to discuss. They are angles who do not share sides and are directly across from each other, and their measures are equal or congruent. So let's take a look at the figure. Angle 1 and angle 3 do not share a side, and they are directly across from each other, so they are equal. Angle 2 and angle 4, same thing. Angle 5 and angle 7, angle 6 and angle 8. So let's take a look at the examples. In the examples, we want to classify each pair of angles in the figure as alternate interior, alternate exterior, corresponding, vertical, or supplementary. So angle 1 and angle 2, here's angle 1, here's angle 2. They sit on a straight line, their measures equal 180, so these are going to be supplementary angles. Angles 1 and angle 7. If I look at angle 1, it's on the left side of the transversal. Angle 7 is on the right side of the transversal, and we learned that when they are on opposite sides, they either have to be alternate interior or alternate exterior. In this case, they are outside the parallel lines. Here are the parallel lines. These angles are outside those parallel lines, so we're going to call them alternate exterior angles. Angles 2 and angle 6. Angle 2 lies on the top of the first parallel line, and angle 6 lies on the top of the second parallel line. So angle 2 and angle 6 sit in the same place on the parallel lines, so they are corresponding angles. Angles 3 and angle 5. Angle 3 is on the inside of the parallel lines. Angle 5 is on the inside. They're on opposite sides of the transversal, so alternate interior angles. Angle 6 and angle 8. They do not share a side, but they are directly across from each other, so angle 6 and angle 8 are going to be vertical angles. You may have noticed that this is going to be very definition oriented. You need to learn your vocabulary. Once you learn what the angles are, what they mean, they're going to be very easy to pick out on the figure. And the figures are going to become more difficult, so it's very important that you learn these definitions and you learn how to pick them out on a simple figure such as this one before we move on. So please study your vocabulary tonight. Pause your video now, and I want you to try these problems on your own using this same figure up here, and bring this to class and we'll go through them to make sure that you understand the lesson.